All right, so starting on exercise 6, I've just opened up a new part file. What's that? And I'm recording. Yep, I'm going to capture this stuff. Heck yes. Like I say, this particular assignment I don't think has any imagery up for there are videos I think go step by step through pretty much every part that gets created that were with the book. Um, what's that? So I have upload. Yeah, so these should be. I got you. Cool. I had forgotten that I did this, but these are the same dimensions that are in your book for sure. Oh, cool. I'm glad I did that. I had forgotten. What's that?
Yeah, opened AutoCAD and started Adventure. Now they're stuck in the waiting for the improvement data.
Yeah, so I do have these, right? Maybe I don't know if I show how far that's extruded though necessarily. So there might be some missing stuff. I'll cover it right now though. Let's go over here. First is pistons, and it's a 2-inch piston. You can put it really anywhere in model space just as long as it's constrained as far as I'm concerned. I'm going to put mine just on the XY plane right there. I'll start my new sketch on XY. Um, and then mine's just a circle, which you should be able to select center if you. So I'm actually just snapping my center of my circle to my origin point. That will constrain it. If you can't snap there, you may have to project it. You can always project a center point, but I don't always feel like you have to. I feel like a circle without anything projected will grab that center. This is a 2-inch diameter. And then that's totally constrained just because the center of the circle is on the origin point. That's an easy way to constrain that one. And so that's the initial sketch that will extrude. I think they just make it 2 inches long. Okay, cool. Yeah, they do a lot of, I mean, I skip over, sometimes I don't always manipulate the way they do, I guess, but 2 inches. Perfect. Let's do it. Extrude it 2 inches. Could go either way here. Maybe I'll just go away from it. But it could come towards you as well. I don't think that's too important here. So this is 2 inches extruding. So I've pretty much got a solid, right? Just a solid. I've got all my origin planes turned on, but I don't necessarily need them now. And then we just do a circle in the center at 1/2 inch, right? So, um, there are some ways like I don't know. Does it say? I don't know what plane it says to put on. The YZ plane maybe is what it says. YZ's right here, which makes sense. It's just intersecting my cylinder straight through the middle. Technically, you probably could draw this on the XZ plane. What would matter is if maybe if you're thinking about how the orientation is going to be on your drawing. Um, I worked with you guys some last week where you didn't maybe draw on the plane you thought was going to be the front view. Some of you individually, I showed that, when you get to your drawing, you have the luxury of once you place a base view, when you initially place that parent or that base view on your drawing, you can manipulate the part around to be in the orientation you want. And sometimes that's the way you'll do that because especially this week as we explore building parts upon parts upon parts in kind of a different way to do assemblies, then it's not going to necessarily make sense that that part is going to be front oriented correctly because I've built the part based off another part that it goes to. And so then I tend to really need to use that manipulation when I set my part on my paper to pick my actual front view. But there also is that, going back to the AutoCAD days, sometimes if I pre-plan out what I want to be my front view, that's pretty smart planning. And if parts are individual, then I can do that. But when parts work on parts, sometimes the front view isn't always like going to be the right front view on my drawing, but I can always manipulate that pretty quick. So to me, it's not the end of the world. And even here, if I choose to do this next thing on either this plane or the other plane, I'm looking for a plane that intersects my cylinder is all I'm looking for. And whether I put it on the correct one or not may not be that big of an important thing here, but so I'll just do, I mean, they do call it out as the YZ plane. So I'm going to do another sketch on this, which my actual drawing plane's halfway in the middle of my part. And so remember, I use that F7 to slice graphics. That slices me through what's maybe in front, and slices me to my plane where I'm drawing. F7 on and off is what I use a lot. It's just cutting that so that I can sketch. And then I see section material as well. That's how I know I'm in there. But maybe I tend to draw when I'm drawing through something, I slice the graphics. And now I'm on the plane that I'm drawing. It wants me to put a 1/2 inch circle. Pretty much centered in here, right? Like centered. Uh, so I'm going to project some geometry here. A lot of different ways you can do this. Like here's my circle. I'll just place it here. Here's my half-inch circle. It's not constrained to anything, but it needs to be on center and on center. So there's a lot of different ways I could constrain this to be centered here. One might be easy for me to do is project this plane's geometry, this one. That's the center line there. So over here, I could, even if I don't have it turned on, I could select it over here for my main origin. If I project that, it's just a project a plane becomes a line. And so for one, I can constrain, like I could do like a coincident constraint center to this line. That drops me for sure. Now this circle is constrained at least to be on that line. Doesn't know which way left or right on that axis. This is just construction material for me is just a projected plane like that. I just need to lock it in left and right here to see where it lives, and it's really in between. So if I do oh, I don't know, if I just do a project geometry of like this top surface, this is like 12 o'clock on my cylinder here. I could project this. What this is it's just a line that is from end to end, that 2 inches that's been extruded. So it has a midpoint on it, right? There's a midpoint on this line. So I could do like a vertical constraint, not on this plane, but on in this case, it would seem like it's a horizontal constraint, but here's a midpoint on this line right there. And I could put this midpoint here. And that's really all it takes to constrain this thing because, and so I've just done size on this, I've used geometric constraints to actually place it where it goes. And I've just used the size dimension constraint on the size of it. So that's one way to do this. This is also construction material, but I'm just kind of like vertically aligning my center of my circle to a center point on that. If my extrusion becomes 4 inches, this thing's going to move for me and stay centered. If I use a dimension to constrain this, which I could have like projected this surface and this surface and then placed them, dimensionally halfway between, but it's just going to be bound by a dimension, and this is going to be bound by geometry. Anyway, so that's maybe how I would constrain mine. I'll finish this sketch, and I have a sketch that's buried in the middle there. I think we do this as a cut through all, maybe. Yeah. Or do I do like an extrusion on this? I can't remember. What do we do? Use an extrude cut. They're going to use a dimension to extrude cut. I'll probably do through all both ways. And then we use a shell maybe, right? Yeah, yeah. Okay, so I'm going to do this cut first. Can't really see it, but if I extrude this, it's actually going, if I go to extrude, it's going to select it because it's my only profile. It's my only closed profile in any sketch that I have, so it automatically chooses it for me. I'm going to cut mine through all, but both sides. So something like this. All I've done is select both sides through all. Now, no matter what that dimension changes, it will cut through both sides all. And then I'll say okay. And then I think it shells this thing, right? Like shell is it's command is pretty common. I don't use shell a ton actually, but yeah, shell command is right here. It's just a normal, it's just like a right there under chamfer next to fillet shell. What does it ask us to do though? It says remove faces. It's going to shell this thing at a specific dimension. I think the default is 0.1 on this. The first selection is remove faces. So in this case, we do remove a face because we want to be able to, we don't want to just shell it. If I shell it without removing a face, it will just be kind of a hollow, it will be a hollow cylinder. And it will also make that same, in this case, 1/10 of an inch thickness around my hole as well. So that it kind of maintains the integrity of this hole through with its own thickness. That's what I'm kind of seeing through here is this 0.1 all the way around. If I remove a face, then I can kind of see that. And I think it has us remove a face, right? I don't think it matters which one you would remove. Like if you remove this end face, let me go here, or this end face. I don't I don't really think it matters. Maybe I'll remove this one. If I say okay on this, it keeps one end solid. It removed one of the faces, the face that I selected, and it kept everything else with a thickness of 0.1. And I think they kept that same thickness. Yeah, 0.1 was there. I think so. I think they just kept it as the default shell thickness. So that's that. And then we just need to we just need to I don't know what. Oh yeah, I do one more cut. So a piston itself is going to get a couple of parts that go through here. So what they do is they end up cutting out this hole that we've actually now shelled, so it kind of is its own little cylinder. They actually cut part of this out, so I only have it on each side. So they use this kind of rectangular cut to cut, and they draw this thing on this. They draw like the sketch here, so they use this end surface, and I can turn these off. They're just kind of keeping my bearings, but this end surface here, new sketch here, right? So I'm sketching on this end. I need to know the center to base this. What it is, I can just drop my shape for. It's just a rectangle, right? So if I use the rectangle command, I just plop this in here. I need to dimension this and then kind of constrain it so that it's going to cut. I think it's pretty much symmetrical cut through here. Um, let's see, what else would I do? One slight thing to remember, because a few people have pointed it out, and I just don't know if I've called it out explicitly, that we've done a few assignments last week that were slot cuts. Just remember that when you're in a sketch, uh, different than AutoCAD, Inventor has a lot more options under rectangle. Like AutoCAD only had rectangle and then like a polygon, and we still have those two, rectangle, polygon. We can draw rectangles a couple different ways here in Inventor, actually four different ways, and then we can draw slots. And so when I drew those, I don't know if we did any together, but I used the slot command to do my sketching of slots, and I tend to probably use this slot command the most, like center to center, and then the radius kind of, or the diameter, I think is how you define this one. So, oh yeah, I selected this particular edge face right here. So not a plane per se, but my sketch and my rectangle is right on this edge, this face edge here. Yep. And then I'm going to dimension this rectangle. What they give me is a half and a half and 3/8 and 3/8, kind of off of center. So I can project, this thing is going to be constrained kind of by to me, the way I look at it is the planes, specifically since I'm centered over my origin here, then I can project this plane and this plane as kind of this crossing pattern here. And then if I dimension this, it wants me to know that this is going to be 3/8, 0.75, 3.75, I think. Yes. That way. It's going to be the same here. So he may use separate dimensions, but I would use the same dimension and have that as a function so that this is my primary input. Those are the same. And then these are going to be dimensioned at a 1/2 inch here. So really I'm dimensionally constraining this for sure. And then this one matches that other one. So it's kind of what I say is symmetrical over the center planes here, like that. Then I might just scooch these over here. So really only have two dimensions driving these. And this is the whole reason why, like when I go, now this is going to be an extrusion cut. What we're going to do is cut this thing and it's going to cut our little inner hole cylinder. But I don't want to cut any of the actual, like this is a piston. Uh, and so I just want to cut this little cylinder in down the middle of it is what I'm going to do. But this is the whole reason why I choose to make these construction lines, or for situations like this, where if you leave them, it's fine. I'm using them to dimension off of, so they're important pieces of data. So if I leave them like this and then I go to an extrude, it makes me pick the profiles because I have this is broken up into four profiles because of the solid lines through it. So this is my reason why, I tend to make these construction lines and then they don't do that, right? So I hope we're getting the feel for that. But it's not wrong to select four different pieces to make the profile cut. Like a lot of people get lazy and they don't turn I don't call it lazy necessarily. They just don't see the need to turn this into construction lines. I just do as drafting practice. But now when I select this, it knows to select that because it's the only profile that's closed. And then this is a cut. But rather than a dimensional cut, in case my piston changed length, and this was just to get going or whatever, I can draw my piston. Then I can just say to face or to next. Instead of through all, which will cut through and I don't want to cut through the end of my piston. I would say to next and select the face. Well, I want it to stop at the inside of this face here. So really, it's only cutting through those two, and then it's stopping at the inside face is what I'm picking by picking this. So it's two, and then it wants me to select a face, which I selected that face. And that's where the cut stops. So yeah, so this is technically the finished part right here. Yeah. And so I have a piston here. If I could choose like remember like your shell command is going to be a feature, and so you could edit the feature, and we can come back in here and reselect faces. So that's probably how I would do is I'd come back to reselect, and I would be like I'm gonna reselect that face. Well, I think first you have to maybe like select them off and then reselect them maybe, or maybe hold down shift. I don't know. Let me see. The thing I didn't say is which way I was shelling it, to the inside, the outside, or halfway between. But yeah, is it shift and then I can adds it back in. Oh yeah. If you have remove faces selected and then you shift select, it will like let you unselect it, right? Yes. You remind me, well, you make me think of one more thing that's doesn't seem related, but it kind of is in my mind, and I'll show you here. Is like so yeah, that's the way I selected mine right there, and so I'm off. I guess the other thing I didn't, I kept mine. If I go back into this real quick, I never did select anything different here. I think the first one was automatically selected, which made my shell to the inside of my sketch, I guess, or inside here. So if I chose to the outside, you could have errors, or it's going to actually change like the size of my part. I just went to the outside here, and it like is kind of like shelling to the outside. Anyway. So just be careful you're actually shelling the correct way. I haven't, mine still is 2 inches OD or outside diameter here. And the tenth of an inch inside is where it's going. So that's what that looks like. One thing I want to show you while I'm in this last sketch, I was showing you the difference between, which I've showed multiple times, the difference between construction and hidden lines. Um, Another thing, in order to like, sometimes when you sketch, you'll have a line over a line, and it can be hard to select that. And in AutoCAD, we could always send to back or move to front, kind of can help us like select the correct line. Here we can, if I have a line, let me draw just a random line over my line here. So I might just draw this line. So I've drawn in some weird random line over the top of my projected line that was a, and so it can be hard to select the projected line. I mean, I know I could come over, or sorry, yeah, my projected line. I could come above it and select that. But if you're right on it, if and so maybe I can't do that all the time. Maybe the line over the line is the same length and I can't get to the one or the other. Right click when you hover over it like this and it highlights green. Like if you right click, select other is what to watch for here. So select other brings up this little drop down list of things that are laid over the top of each other. And this is how I can like once I drop, and this can be kind of tricky to get to. Sometimes you hover off it for a minute and it's gone. But here is one curve segment that's over the top of the other, and here's the other one. And so remember you can like just hover over this geometry where you may have 3 or 4 lines over the top of it. And it can be hard to select the one, whether you're trying to dimension one or whether you're trying to constrain to one. Just know that you can hover over where all that crap is intersecting it, right click. I think if you even hover, anyway, right click and look for this select other option. From the drop down menu, you may have several that are over. Now, see, now it actually shows me 3. I've got actually that curve line, they call it a curve, this sketch line, or even the plane itself is all on that, is all kind of lined up. That can be helpful to continue to add dimensions or other constraints to it and pick the correct geometry that you're trying to get. I don't think I showed that last week. That can be really frustrating. I tend not to delete stuff just to try to get underneath it or whatever. I'll use that select other method, that right click. So if I select the item and right click, I don't know if I get the select other. It's just me hovering over it to where it lights up. Light up here, select other isn't even an option because in this case I have nothing overlapping it there. And of course I didn't really want this one, so I can delete it. But yes. So it's not the end of the world. Don't worry about deleting it. Just go to the select other to choose which geometry you're actually looking to use. That comes up in other ways too, I think, that select other method. I'll try to remember to point out when I use it. This thing is done though. I think that is the end of this. Yeah, yeah, this one's done. So I'm just going to name this. You can name it whatever. I think I just called it part one. It is a piston if you want to. They may say to name it piston one, right? Yeah, whatever. That's fine. You can name it that. Um, I'll just name it something. And I will put it in my week threes files. Here's my week 3. I did call mine just part one, but you can call it whatever. or you can call it piston. Next part, new. That might be the most complicated one. I think there's one more that's kind of. I probably can get all my parts built actually. Let's do it. Like I just build, create new part. What I'm saying that we're building here though, like we're approaching an assembly by building it kind of part by part, and they're not really related, right? Like I'm just opening up a new part file, just using the dimensions, creating it. It doesn't have any relationship with any other part that I've built. So this is just one way to do it. I feel like this is kind of the old timer way of doing it. I worked with some people that I think had self-trained into, from CAD into Inventor, a couple of older drafters. They just felt like their assemblies, they would build their parts as total individual parts like this. And that's why I'm going to show you a different method as well that I feel like is more conjoined and to me makes a little bit more sense. But this is definitely a way to do it. You just build individual parts and we'll assemble them in an assembly. And that's kind of where we're headed. Individual parts. So really I'm just making a new part. Did I already make one? I did. Part 2 right here. I haven't named. And I don't think I think it's probably on the XY plane we sketched this one too. It's called a wrist pin, I think. And it's just a simple cylinder. It's the pin that goes down that hole we created in our piston. And so, yeah, I think they just use the XY plane again. New sketch. And this is just I think they just make it with a circle as well. And it's what in diameter? Half inch in diameter, 0.5.
Yeah,
Yeah, I just did it on the XY plane and I just started the center of my circle on the origin point. So it's already kind of constrained for me. It's kind of an oddball length where they make it like 1.875. That's 1 7/8 long. And so I'll finish this. And then they extrude this thing. And they extruded it 1.875. Sometimes you'll see me extrude this away. The only reason is because sometimes this is the way I take my imagery and I throw it in the assignment so you can see my sketch and the thing. It wouldn't matter on this one which way you extrude it either, except you will see when I come back, sometimes I will want my origin planes to be in the middle, and I'll show you why. Right now, I'm not going to worry about that. I'm just going to tell you that in the future, when I go to put this in an assembly, I end up changing sometimes how I'm extruding around my sketch. In this case, you wouldn't know that yet, so you're like, okay, that's great. It just puts my origin planes, on one end here, and there could be a reason for putting things in an assembly. There can be a reason why I might want my origin plane to be in the middle, and so then I would have like 3 planes right in the middle of my part. I can use them for like assembly constraint purposes, but you'll see why in a minute. And right at this point, I don't care which way you extrude it. We can always change it later. And this thing is done. This thing is a half-inch wrist pin, so I just save it as part 2 or something. I just call mine part 2, but you can call it the wrist pin if you want to, like the book says. How long was it? Was 1 7/8, so 1.875. Yeah, and I can't. I've got in class. How about we make that in class? Love it. The other reason why I kind of went and made a new assignment based off of this is because this part right here is going to end up, this part is going to insert into this part right here. The wrist pin is actually what goes in between here, and then it hooks to a connection rod. And so really what we have here is a half-inch circle and we have a half-inch pin, and this would be like a 0 chance of fitting each other. This is like a size on size. And it's okay for doing this as like a introduction into assembly. But that's why I created another one, is to actually introduce some tolerances, because technically this is a situation where you wouldn't make the hole that goes through here the same size as the part that goes through here. There would need to be a tolerance applied. Like I could model it at 1/2 inch like I've done, but on my drawing, I would probably definitely want to say +0. It'd be almost like a bidirectional tolerance I apply. It could be -0.002 or +0. I'd never want it to be bigger than a 1/2 inch. Or I could add the tolerance to the hole per se. So one of them needs to be tolerance, or maybe both of them do, so they work together. Um, anyway, so we'll think about that when parts go together. Right now, you wouldn't necessarily know those parts go together, but they do. So that is the in-class wrist pin, or just part 2. My third one is the actual, what they call is the, maybe it's the case, or do they call it the crankcase? What do they call it? Look and see. Piston case, maybe? Oh yeah, piston case, what they call it. This is gonna be what the piston fits into. And so my new part here is just another new standard part. And I think I just pretty much didn't worry about which one is the front view. I think they put it on the XY plane. I'll just see if they actually call out a plane here. I'm on page 16-7, or sorry, 6-17, but it's I really don't think they even call out which plane they're even making this on. So like I say, it's not going to matter, especially this way. I'm just going to do it on the XY plane, kind of keep it the same that I'm doing. I would say why we use the XY plane so much is because it's the preloaded front view plane, and it kind of is the AutoCAD similar plane XY. So in a lot of cases, that's why I'm choosing it. Kind of, and then this thing is just a little L-shaped part design, so you can sketch this out. Maybe I'll draw mine in real size, and then I'll constrain it in where it lives, though. But this is going to be 3 inches. I'm just using the 3 inches, and then over this way. Sorry if I zoom correctly. There's my perpendicular constraint. We go 8 inches, yes. Then we're gonna go. I gotta zoom out a little bit. Then we're gonna go down this way. Look for that perpendicular constraint to be 0.75, and then back this way. Not it hasn't given to me, but it's the difference of 8 minus 2 3/4. That'd be 5 1/4. 5.25. And then back down this way to where I should be able to align with that when they're all perpendicular. I think the C for close work here. Enter C, enter. I don't think so. That's an AutoCAD one. You can usually close a polygon with C enter. Here I'm just gonna snap over here. Escape there. Snap. There's my close shape. It's dimensionally kind of constrained, but it's not in space constrained. So I'll constrain it anywhere really. I don't care how, like this one might be how I did the last week's ones. I'll just pick a point on this. I'll pick this bottom point and put this point here, this center point. Sometimes I'm just choosing to constrain stuff from the list over here. That's why I always expand my origin in my model browser. So I always have access to my axis. Oh man. And my planes and my center points always at my disposal. Finish this sketch. However you wanted to constrain it is fine. And then this thing just gets extruded like oh wait, what does it get extruded? 2 1/4 inches. 2 1/4. I'll just extrude away 2.25, enter. And then it says we want to do some fillets here. Use the fillet command to create an 1 1/8 fillet on the front portion. And so that works because they're saying make an 1 1/8. Remember this too, right? Like I do a lot of measuring. I'll turn off my planes real quick. I do a lot of measuring on my thing. Uh, Here's measure. I just right click in any. I'm not in a command at all. Right click. Here's measure. It'll let you just keep measuring. Like here's a face-to-face measurement. 2 1/4 is what we extruded this. Half of 2 1/4 is pretty much the fillets that they're giving you in this. Sorry, not that one. This one. I have a calculator somewhere. I can grab it. There it is. 2.25 divided by 2 is the 1 1/8 that they're calling out. So yes, it would work, right? Like fillet works pretty good to say fillet, put in the dimension of your fillet, 1.125. It wants me to select edges, which these two would work because that is correct. I mean, that works because they don't conflict each other because an 1 1/8 is half of 2 1/4. That's one way to do that fillet, which I think they have in the book. The other way was a full round fillet, right? Also does that because it lets you select 3 different faces, this one to this one to this one. And now it's not necessarily dimensionally. Now, whatever I would change that extrusion length to, it would always full face round that. So there can be reasons why that's better than the other, depending on if this thing's ever going to change in width or something. In this case, it's actually maybe the depth, I guess, but if that's my front view. Yeah. So anyway, either way would be good way to do it. But what do we got here now? You just have to put a hole in it, I think, right? Or no, a couple holes. Got to put in where the piston goes, which is right here. And so it has me do a sketch right on this little inside square face. So I'll do a new sketch here. And then it just wants it's a 2-inch circle here. So I can draw my circle and then I need to constrain my circle. So here's my circle. Here's going to be in here 2 inches in diameter. And then I just need to constrain it. And they have it up 1.25 inches and 1.25 inches, or 1.125 inches and 1.125 inches. So I think that's centered, but I don't know. Like I can measure this. We do a couple measurements here. Like from this point to this edge here. That's 2.25. So that makes sense. It's centered that way. And then it's this way to this way is 2.25. We know that's the way it's extruded. So really they're placing this thing on center. So you could use just geometric constraints to constrain this, as though maybe how I would see this is maybe I would project just two pieces of geometry, like maybe this edge and this edge. I've got these two like edge lengths. And then they have, I can horizontally constrain this one to a midpoint here, bam. And then I can horizontally constrain this one to a midpoint here. And then that's the way I'm constraining mine.
Is like that kind of constraining the dimensional?
I don't think it matters. I would say one is better if you know the part's going to change. And so sometimes when I'm like getting a model ready for an engineer for us to talk about, sometimes I don't know the exact tolerances. Sometimes I don't know. Um, Maybe we have some discussions to have on design, but I can get a lot of stuff done and ready to like introduce actual dimensions to. And so I think you'll find in that, and I feel like in your later in your drafting career, especially when you fall into the designing phase of your drafting career, you can do a lot of like pre-building, and then you can have something to look at and discuss. And then you have built when you're a good designer, you've also built parts that aren't so dimensionally like heavy, and so they're easier to get in and modify. That's why you can have quite a bit built, have a discussion on design. And then after that meeting, you can go back in and just start putting in the right dimensions and have something that's like ready to go now pretty quickly. Now, if you've put in a lot of dimensional constraints to do that, it can be just a little bit slower on you. If there's things they're going to stay centered, always stay centered, then it's, to me, if I know things are centered, I tend to use geometric constraints more than dimensional constraints. That way, if I change the size of stuff, that thing always stays centered or whatever. So I don't know. You'll look for these relationships in your career where you can speed yourself up in design and but really the way you know that is when you've actually probably done everything dimensionally constrained. You realize this is a lot of dimensions to change. Maybe I could have geometrically constrained this and sped me up. So I think it'll come with time. Give yourself patience, so the short story answer is no, it doesn't really matter. You'll learn later that there maybe was a better way. Yeah, good, better, and best. One of my most favorite quotes. Sorry, you're gonna make me go into quote land, and I wish I could just say it. The way I paraphrase it isn't as good as the real quote. It's old Teddy Roosevelt, that is. Um, Here's my favorite. I don't know Teddy too well. Me and Teddy don't know each other real well. He says, in any moment of decision, the best thing you can do is the right thing. The next best thing is the wrong thing. And the worst thing you can do is nothing. So I love that quote because it shows you that your wrong decisions they're just actually the next best decisions. There's always the best decision. There really are no wrong decisions. There's just, the next best, which sometimes we call wrong. And then but the actual worst decision you can make is just to be a landlocked and can't make a freaking decision, right? Because, then that is the worst decision. Because, if people are shooting at you and you can't decide whether you run or shoot hide or whatever, if you just make no decision, you're probably gonna get shot. So you should have just made a decision, run or hide. I don't know. That's a horrible thing to think about, but that's not the best place to apply that. But that's quick making a decision. In the case of dimensioning or building, there is no really wrong. there's always just good, better, best is what I say a lot. But I love the Teddy Roosevelt concept of like, in your life when you're making decisions, you're not making wrong decisions, you're making the next best decisions sometimes. And then the best position presents itself later. So, and I probably by looking at that quote, it seems like I just like opened myself up to like a bunch of spam. So I had like pop-up boxes going everywhere. Okay. So don't think of yourself as making wrong decisions. That's how I live my life. All right. Extrude this thing. It's just a cut hole. Yes, extrude, cut. Through all is what I say. Just dimensional constraints are so absolute, whether it's like an extrusion or whatever, they are just absolute dimensions and they don't change for you automatically. So you can see I minimize dimensional constraints as much as I can. Let's see here. But you could have put in that dimension too, right? Whatever this dimension is. I just don't know it off the top of my head. But here's another, oh, let me show you one more thing that we don't do. Like when I'm in an extrusion, like when I'm in an edit feature, and yes, you can go to this box and enter that value. That ends up being 2 3/4. You can do what I do, which is pick, like to go through all or sometimes two next. But on the little arrow here, you can measure too. And this little arrow shows up in a lot of different, on most dialog boxes that allow you to put in a dimension, there'll be a little arrow next to it like this. And this can be really handy if you don't know the dimension of something, but you do want to actually put in a dimension of how far this is. You can measure it. So you can just say, oh, let me measure this. Then you're kind of in this measurement command where you say, oh, from this face to this face is how I want it to cut. And then it will populate that dimension for you in your dialog box. So that is really handy. Just you're in the middle of a command. Just remember, if you ever see that little arrow next to it, it's a place to maybe quite a few different things actually. It has, I don't know, it has some of the stuff I've previously used. I think this is preloading some dimensions I've used before, but that measurement tool is really kind of handy. You can measure point to point detail, face to face, line to line. You can measure a lot of different places. So that's handy. In this case, I'm still just using through all, but use that little measurement trick on populating a dimension is really handy. Um, I think this thing is almost done. We just need a circle that's concentric to the circle that's sharing the fillet circle here. So if I do this sketch, I think you can do either, I think they roll it over to this back side or this top, but you could also sketch on this plane as well. To me, I don't think there's a good, better, or best here. Just a new sketch, because all we're wanting to do is put a hole in here. So I'm going to project the radius that will come with its center point that I can lock into. This to me is construction material. Really what I needed was, I know that can be kind of sometimes painful to turn on, but I just need that center point. And this circle, I'm going to snap to it. And then I'll put in the dimension they give me as a 1/2 inch circle. And then I just say, okay. And then this is going to be a cut through as well, right? This is going to be an extrude cut. It's just a hole through. I'll just say through that thickness, which is 3 inches in that case. This might be one that if you do through here, it knows that the original part is 3 inches here. And so it's going to cut 3 inches. That could be detrimental to a part if you build something up here and this cut's going to be cutting through whatever you build up here. So this one might be a 2 next as a better option. I only want it to cut to this next surface. And in the event that I add anything into this solid up in that area, I don't want that hole to be cutting through it. And so I would say, okay, so just be aware of what your dimensions are. That was, if I'm aware there, I'm watching for what I really want to cut through. And then I think this part's done, yeah. And that's about the end of our class. But I'll probably go through and finish mine here before. I'm gonna do this all as one video and do my next. I think there's just a couple more. This is part 3. Yeah, I'm gonna save. I only got 2 more parts. Save it. I'll do it quick. This is part 3. Or you could call it piston case, like the book says. Let's do another part. I think this next part's maybe the goofy one, but not too bad. Create. I think I pretty much started on the XY plane as well. The XY plane. I think they have us run through some dimensional. I think he does apply some. He kind of shows you how to maybe start to constrain something. I can't say. I felt like I followed along with the video and kind of watched it one time because I think he does a couple different sizes of holes and then he kind of shows you how I make them the same with, and that's fine. Like some of it we know, but I think if I just start on the XY plane sketch, he shows that, oh, I'll put a circle here and then I'll do another circle. So if I right click, there's my center point circle in my quick access here. He does one bigger than the other, right? Something like this. He maybe dimensions them from center to center at 1 inch. I think he makes them equal sizes. Yeah, I think he uses this equal constraint, which is a great constraint. You can set them as both equal, even though they don't even know what size they are. They're gonna self-adjust to be equal. Probably whichever one I selected, either first or second. There might be an order of operations of which one we equal, but I think eventually he ends up dimensioning this as you only need one dimension here as 1 inch, I think. Yeah, I just use this is an equal geometric constraint right here. So if you select it, we've used it in the past last week. Select it, and then you select something, and then you select the next one. So I think you're first choosing what you want to match the next one to, kind of like match properties in a way. Like select it and then select the next one, and it'll make that second selection equal to the first, I think. And those constraints will show up if I actually select this object. There's an equal constraint that's being applied. And so they're both 1 inch by 1 inch. And then I think he actually did just draw some lines from quadrant to quadrant. See it? Yeah. Line from quadrant to quadrant from here to here. Not trim yet. I'm going to do another line, create line. And that to me is very similar to CAD. Like once I exit a command, like when I'm in a command line command and I'm drawing something and I draw it, I right click and I'll hit OK, which is kind of like I would do the same thing in CAD a lot. If you ever watch my videos, I do a lot of right click and hit OK to kind of exit my command. And then if I want to go right into the command again, rather than use like a keyboard input, I will like right click out here in space. And generally, whatever you've used last will be in this little like it'll be one of the options you have that's in your quick access little display here. So there's my center point circle, my create line. So I will use my right click to go back into my commands right away. So I use that a lot, even though I don't say that, but I'm doing that. And this, of course, I didn't need. That's just garbage. But so this particular shape isn't too like constrained. Like it doesn't know what is vertical or horizontal on those sides at all. So it's kind of a mess. Um, and it doesn't really know, it didn't really hold me like tangent either. Like I could apply a tangent constraint, when you see a line that lets it intersect a circle like that and move. If I could put a vertical constraint, I could put in a tangent constraint to the circle. A lot of different things could be added here. I'm just going to add a few. I don't know. Maybe I will just do tangent first. Tangent this to this, because that's clearly wrong, and this to this. That one says it already exists, so that's cool. I'm still in the tangent command. Maybe I'll say this to this. Says it already has it. Good. I'm just double checking. This one clearly doesn't have it. There it is. I still think it allow you to pull these things potentially out around. No, that one's now horizontal. It has that. Or a vertical constraint. It has it. Um, I think I just put this. I think they trimmed this. So if you trim this can start to affect your constraints as well. Like you may have had some geometric constraints that kept these black, and then you go to trim it, and then they become purple again. It means you have to reapply some constraints if you've trimmed them out. Another way to do that, if you do have, let me try to get this to do what I'm thinking it might do. I'm going to put these back in. I'm going to go ahead and yeah, I'm going to constrain this in my space here. So I'm going to use like a vertical constraint to the center point here. That's going to push everything over. I'm going to do maybe a geometric or maybe a dimensional constraint from the center point to this point at like a 1/2 inch. And that's all that took to constrain this thing. I'm using a vertical constraint to center, and then I'm using kind of a dimensional constraint to place it over center, which may or may not be the best way to design this. And then if I trim this, I just want to see if when I trim this out now, like this is a fully constrained shape. If I trim it, does it start to affect its constraints? Maybe, I don't know. So let me see. Trim this out, trim this out, trim this out. It doesn't on this case. Sometimes you will have it like sometimes you will have it affect its that it's not constrained anymore and stuff starts to turn purple again. And then you've got to reapply dimensions or geometric constraints. Some ways I can avoid that when I'm instead of like just trimming straight out trimming geometry out. Not to say that I wouldn't here because that worked well. That'd be fine. But another way you can do it is like split up some geometry because I could split those circles into kind of halves. Like I could come up here and be like, these little X's show up where I'm splitting this thing at. Like I could say, hey, split this one here. And then I could come down here and say, split this one here. I don't maybe want to split it here. It's going to put a split in there. But I could say split here. And then I have two separate pieces of geometry now. And this thing could be turned into construction geometry. This thing could be Yeah, it's just a normal modify command is split. I don't think they've used it in our book at all, but I will split my geometry like this. Of course, it's going to be, and you can split around construction lines or you can split around solid lines. So the split command will accept both. It doesn't have to be a solid line to accept it. But the reason why I might do this is if I had like, I have this nice fully constrained sketch, but I really just want to kind of like trim stuff. And then once I start trimming, everything starts to be unconstrained again. And that can be a nightmare to kind of track down. But maybe I just keep the geometry, split it up, turn it to what I want it to actually be, like use the stuff I want to use and turn the other stuff to construct. So this is some ways I will do this in a sketch too. So I do both ways, but just be aware that there's more than one ways to kind of like uh, not affect the constraints that you've applied sometimes. And that this could be one that's beneficial. Yeah.
Full constrained, you can.
Like nothing, you can't get this to constrain in space. Oh, well, yeah, maybe you need to like constrain like one point of one circle, like this would be a vertical constraint to the two. Maybe they don't know to be. Mine, I may have actually, when I snap those two circles, I may have actually not noticed that I had like a vertical constraint already going. So you'd want to definitely have those two like in line. This would be a vertical constraint from point to point. That would keep them. Is that what helped? Yeah, I think mine, I didn't even realize that I had applied it, and it was one of those grade. But if not, just like move those two in vertical alignment. Yeah, good. I'm glad that's what that was. And even this sketch wouldn't, you could leave it this way. I mean, it doesn't know which profile I'd want to extrude, but technically there's four different profiles here. There's two circles and uh, these two little wedge shaped pieces that this would totally be able to extrude as a solid. You just have to select more profiles. And so I mean, there's maybe good, better, and best here too, but I chose to split mine. You said you had some issues splitting though, Arya, potentially. Yeah, this is split, and then I could still like it won't let you split geometry if there's just like I'm hovering over this and it's not even allowing me to split. There's nothing to split here on this necessarily. There's no intersecting geometry. And even on this thing here, there's nothing to split here because I've already split it here and here. But I still could split this down the middle where there is some intersecting geometry. So technically, in order for the split command to work, it has to have intersecting geometry. Oh yeah, so that could be true. Maybe you can't split stuff if there's constraints holding it. So if you've dimensioned yours different than I have, maybe that's not working. Because that might be trying to prevent an error. Because like if you were able to split there, it's going to be unconstrained geometry, and so it's trying to prevent that from happening. Well, maybe delete some dimensions here or there, and then see if the split command works. But in this case, it wouldn't be maybe I wouldn't necessarily do that. I think the trim command would work just fine, but I think it's nice to know different ways of like that's how what I've done is just simplify my profile here to where when I escape this and we need to turn this into a quarter-inch extrusion. 0.25. Oh, perfect. There you go. This is just a quarter inch. This one's done for me. I think I have to put the couple pins on it, right? So sorry, I'm gonna select all these and turn off my origin. Well, I thought it was.
Do you want all of these parts individually or?
Yeah, these are going to be like 5 different parts that are turned in. Yep. For exercise 6, yeah. Mhm. Yeah. I need to update some of my rubrics I know this week. My rubrics probably don't match what I'm really looking for, but mostly it's just 6 different parts. And then what do we got to do? We got to add the circles and the shafts to these. I don't think it matters which side of this I choose. Here's my front side here. Maybe I'll start with this side. I'm gonna do a 1/4 inch, 0.25. Mm-hmm. This is the crank shaft. I think that's what they're gonna call this at the end. Yeah, this is gonna be my crank shaft. So here's front. I'm gonna do a sketch on my front, and I'm gonna project this geometry here. At least this is I need a center. I need to know where this center is. When I chose to project this, it also projected the center point of the actual center of the part. Those just came, free of charge here. All I'm looking to do is place a center on this concentric to the outer radius, and this is also 0.5. You got size on size going all over on this thing. And then I think this one, yeah, they just finished this sketch. They ended up extruding this thing 0.25, which is what my last extrusion was anyway. So that's that. A little 0.25 extrusion on that. And we do the same. I go to the other side of this, so I flip it, whichever side you drew. I'm gonna do another sketch. I'm gonna project that piece of geometry. I'm gonna turn it into construction work, and then I'm going to add that. Sorry, that should be 1/2 inch. Same size as the other size, 0.5 inch. Finish that. This one, I think, how far do they extrude this one? I think they just do 0.5, but what's that? No, no, no. It is kind of the opposite side, but opposite. Yeah, exactly. I don't feel like this is the right dimension, but I think they do this at first and say it's 0.25 like that. So yeah, thank you. Got it. Appreciate it. So I think it ends up being a part like this that we maybe have to modify once we go to the assembly. But I think that's it for at least saving it. Save it now as the crankshaft, or I call it part 4. So let's see. And then I have one more. I'm gonna do it. I know it's way past time. You guys gotta leave. Take off. It's good. You'll see what I'm doing. I'm just building the last part here. Create it. It's the connection rod. And I'm pretty sure it goes on the XY plane as well. So I'll start my new sketch there. They show this as they kind of walk you through geometric constraints a little bit, like like they draw 4 different circles. Then they draw, it's similar to that last shape we just drew. It ends up being, but they definitely show you concentric, they show you equal. Um, so I can do it this way, the way they've kind of done it. They kind of just show what they like throw a big circle here, then they throw a little circle in here, then they've got another big circle down here. It's just totally like randomly built shapes. I think they use the concentric command, which I don't think we've used much yet, but that's this one here. Circle on a circle is concentric constraint. So I'll just say this one to this one are concentrically constrained. I'm still in the command this one to this one. So there we go. That's one way to line them up over each other. And then they line up the centers with what was that last thing you needed, Kelsey, was just to do like a vertical constraint from center to center. That'll line those two up over vertically over each other. And then I'm going to do some, I don't know what they do. Do they do equal constraints? Yeah, maybe. I know that in the end that I can apply these even if they're not right. The bigger circles, that one is going to be equal to this one. And this one is going to be equal to this one. So that's pretty good. I'm going to add some, once I dimension one of these, it'll shape the other one. So maybe I'll do that. This outer dimension of that is what, 3/4? And then this outer dimension is 1/2 inch, I guess. And then I'm going to put in my lines that are going to be hopefully tangent to tangent. Let me snap this. You can see that that tangent one is showing up. That one kept them tangent to tangent. I just kind of was paying a little bit more attention that once I clicked here, come up here to this quadrant, I'm looking for that little tangent one to show up. I can see once I left click, I see both tangents showed up. So that should have applied tangent constraints. I need a dimension here between them. They say it's 2 1/4 between center to center here. You don't have to pick center to center. If you notice this on circles too, you can just pick circle to circle. It's going to want to know that center to center. Some things it automatically apply, it knows it's 2 1/4 where you're trying to dimension to. I'm going to use here's how I'll constrain this one. I'll use a vertical constraint for this, for the center. They're already vertically constrained together. So I'm just going to select one and my center point here. If I can't select it there, I can always select it over here. So that pushes it centered over there. Now I'm going to do a horizontal constraint. These will have midpoints on them because they are kind of bound tangent to tangent. So I can actually just say, hey, one of these midpoints to this center point, and that is now fully constrained. And it's kind of symmetrical over the origin, essentially, right? Like I've centered it over the origin this way. Pretty common when I'm building part that's unrelated to a part, I'm probably going to center it over the origin. If I'm just looking at strictly a standalone part, it'd be pretty common for me to probably constrain it this way, center to center, over the origin planes. Might even be common for me to extrude it. Centered over the plane as well, so I don't get an offset extrusion, but we'll deal with those when we need to later, and we'll see why. And then maybe I'll split mine here again. I'll just see if this breaks up this one I don't need, and this one. So I'm splitting these here, and then I'm turning this into construction material. It's just a lot like CAD, and that I don't delete stuff if I don't need to. Some people, the way they draw, they just delete a bunch of stuff, but I don't. I like to split it up. So this thing is now able to, I think this will, technically I have 3 different profiles. I have the whole profile, plus I have the 2 circle profiles. So when I go to extrude it, it'll need me to select what I'm extruding. That's it right there. And I think they're also a 1/4 inch extrusion. And I'll go away originally here, and then maybe I'll come back and change that later. Because what I say is my go-to on a totally standalone part like this, like I'm creating it in relation to nothing, it would be most common for me to have my part pretty much drawn centered over the entire origin planes, if that makes sense. So that the 0 0 0 origin point is directly in the middle of my part here. I'm going to go ahead and push this to one side just because. And then this part is done. And then our 5 parts are done. Tomorrow we'll do the first assembly of all time, and then we'll jump into chapter 8 and how to do actually an IPN part. And so really by tomorrow, and I look at my browse templates here, if I'm going to start a new one, we've already covered this one in pretty good detail, just never done a sheet metal part yet. We've done none of these yet, so at least we'll explore the standard assembly tomorrow. We've already done at least an ANSI drawing, an IDW drawing, and we've never done an IPN. So by the end of this week, we will have done one of each of these now, which is critical. We've seen all 4 of the options I have, at least the main options under in Inventor. Next week we'll do weldments, so we'll learn this. We'll learn maybe it's pretty much like a standard assembly, but I can do some welding things to it. And so next week we'll do weldments. Mold design, I don't have any specific. I think this has showed up newer. I don't know how long they've had a mold design specific assembly, and I've never used it yet. So that's interesting. I can't say that's been there. Maybe it showed up in 2020. I don't know when that showed up. Maybe I'm wrong. It's been there all along. But. Okay, that's it, you guys. It's Monday. We got started. I got to save mine here. This is my connection rod, or I'll call it part 5. So, heck yeah. our skills have paid off from last week because now we know how to build.